Yeah, welcome everyone to this Product Talk series by Pragmatic Leaders. We are glad to see you all here. Before we start today's session, I would like to give you a little brief about Pragmatic Leaders. At Pragmatic Leaders, you all are part of global family of aspirational professionals who proactively help each other and are invested in each other's career growth. Pragmatic Leaders functions like a full stack global career accelerator that rests on three core pillars. Pillar one is educate. We help you upskill via proven courses and professional industry coaches. Pillar two is engage. We run a global product community of product managers and AI enthusiasts on Slack with access to online and offline meetups across the globe. And pillar three is employ. We operate a job platform and dedicated interview preparation courses to help you crack your dream job, along with some longer duration job guarantee programs. You can check them out at our website. I'll share a link of our website in chat section. So that's all about pragmatic leaders. Pallav has also joined us. So Pallav, I would like you to introduce Gaurav a little bit before we begin.
Right. Hi, Gaurav. Thanks for taking out time today. Um, as we all know, that Pragmatic Leaders has been a kind of a pioneer in educating people and getting people to become good product managers. In fact, become great product managers. And now we have embarked on the journey of educating product managers in terms of how AI will help them become better in the what they do, right? And in that journey, we have launched a course for which we are already running a batch, and now the another batch we are filling in. So the batch is live on the website. To talk about Gaurav and why did we bring Gaurav today is just to make every one of us understand that how today globally companies are using artificial intelligence to build their products, and who better than Gaurav could have been here to explain us that, right? So about Gaurav is a PM lead at Google AI and leads 8 teams spanning across NLP and computer vision. He drives the tech and go-to-market strategies for key research technologies, both in B2C and B2B products. He actively advises startups in the areas related to AI and product growth. He enjoys teaching and has taken guest lectures at University of California, CMU, IIM Kozhikode, and more. So, thank you, Gaurav, for coming over and taking this session. And over to you now.
Awesome. Thanks a lot, Piyush. Thanks a lot, Pallav. Hi, everybody. As both Piyush and Pallav mentioned, my name is Gaurav. I'm joining from California, so it's a little early for me. If I seem a little sleepy, please blame the time difference between the two countries. Awesome. So I'm happy to kick things off with the session today. As Pallav briefly mentioned, I'm a PM at Google AI. What that roughly means is that Google AI is the central place at Google that focuses on building a lot of cross-functional, cutting-edge research technology in different areas. And as a product manager, I am basically responsible for evaluating how can we take that technologies to market. And by market, I mean embedding in different types of Google products, or it could mean potentially like externalizing it through Google Cloud APIs and stuff. So some of the things I've been closely involved with, one focus area for me primarily has been around conversational AI. So I've been involved with some of the chatbot related research and projects at Google, which was called Project Mina. And the other one is related to smart replies. These are like small chips that you probably see in a lot of messaging apps across Google ecosystem and other places. So I've been heavily involved in the on-device smart reply area. And then the second high-level focus for me in the last couple of years has been around Edge ML. This is basically where you actually transfer the machine learning technology on the client side and let the models run there for privacy and more efficiency. So here's an agenda for today. I'll roughly be spending about 35 to 40 minutes on the presentation, and then roughly take about maybe save about 15 minutes for Q&A at the end. I'll start by quickly giving you a quick overview on what is AI. I know a lot of people struggle to kind of grasp the overall concept and how is it related to machine learning, deep learning, blah, blah, blah. So just giving like a quick overview on that. We'll dive into slight bit of like some of the ML solutions that are out there. We'll get into some generic case studies. I apologize, these are not related to Google because of, you can probably understand, because of sensitive issues, I'm not allowed to talk a lot about Google products. So I've taken some generic examples of case studies. And then lastly, we will get into some of the ML consideration and resources that might help you as like product managers or leaders in company to incorporate AI. Awesome. With that in mind, I just wanted to quickly get a sense of where the audience is in their journey about AI. So if you can use the chat box and just let me know where you are between a scale of 1 to 10, where 1 is like you've casually heard about these things and don't know much. By these things, I mean AI and ML. 5 is more around, hey, you know about like TensorFlow, PyTorch, and you've kind of played around with some of these things. And 10 is you know what SGD is and you can explain it to a 6-year-old. If there is a way you can potentially add these to the chat, that will be awesome. And I probably need to figure out on my side on how do I look at the chat. Okay, yeah, I can see the chat window now. Great. Okay, so I see a lot of 1s, 2s, and 3s in here. Okay, there are a few 5s, 6s, and 7s as well. Cool. Actually, sounds good. This is actually great because this presentation is more aligned towards people, I would say probably between 1 and 6. So the ones I see writing 7 and above, probably, I don't know how much relevant this would be. So hang around if you feel that this is too basic, feel free to drop out. Awesome. So as I said, the goals here is just to give you a high level understanding of AI. And how you could potentially leverage them to build or improve products in your companies. Non-goals here is we are not going to dive deep into like machine learning model development. It takes much more time to kind of get into those details. So we will not do that or get into the technical details of like building models through TensorFlow and stuff. And we are not going to talk about general product management. Awesome. So let's dive in with the first section, which is around demystifying AI. So there is this concept where everybody is kind of confused about, hey, what AI is. So put very simply, AI is essentially the science of making artificial things intelligent, right? And artificial things are everything from your air conditioning to the games that you play to the cars that you drive. And just to take a step back, AI is not a concept that is new. Since the dawn of computers or even before that, we have been trying to make artificial things intelligent. Take the example of the air conditioners that you have at your home, right? There is a simple decision-making mechanism in that, which says that if the temperature is below 28 degrees Celsius, then turn on the cooling of the AC. So that's actually making the air conditioner a little intelligent, right? And the chess game, probably if you have played, if you're my age, earlier, where you could potentially play it with a computer. So it's essentially a way of making machines intelligent to help us in different ways. Now, in the more contemporary times, artificial intelligence is referred more to a field in computer science that actually is aimed to make machines to come to like human level intelligence. So essentially going from just having a decision tree where you say if the temperature is less than 28, more than 28, turn on the AC, it's actually trying to achieve human level capabilities. And let's try to dive a bit deeper into what human level capabilities actually mean. So let's take an example. If you see an image of a dog, right? For us as humans, it's really easy to say, oh yeah, this is a picture of dog. But how do you actually make a machine or a camera basically figure out it is a dog? Similar to that, if we hear, let's say, somebody shouting in an adjacent room, you can totally figure out that, hey, somebody is actually angry. How do you actually make machines figure that out through inputs and understand whether somebody is angry or sad? And the third one is, which is like if your friend always sees, let's say, superhero movies, we know that if a new Spider-Man movie comes up, we would actually want to go with them or want them to see it because they kind of love it, right? So these are just some examples of human level intelligence, but these are extremely difficult tasks for machines to do. And artificial intelligence essentially is the science of how do we get machines to do some of the things that humans can do, like very naturally and very easily. Uh, cool. So the natural question, the next natural question is, how do we make artificial things intelligent, right? We do that by building algorithms that can actually learn by themselves. And what do I mean by learn by themselves? One way of making things intelligent is through using decision trees, like the example I was telling about the air conditioning, right? If your temperature is more than 28 degrees in the room, turn on the air conditioning. It's a decision that you have actually embedded in the system. But what if I don't want to embed all these rules in a system? So in that case, we use this technology called machine learning, where the algorithms actually can learn from the data. So all we do is give a lot of data, and then based on that, they figure it out. Let's take a simple example. Imagine you are a product manager at Netflix or Hotstar, and you have only one notification that you can send to me as the user, recommending a movie. What movie would you recommend, let's say, between Batman Returns and Fight Club? Cool. So as humans, it's easy for us to understand. Let's say I like Avengers and I like Spider-Man and I like Iron Man and I don't like Shutter Island and I don't like Titanic. So there's a clear pattern here where you can say that, okay, Gaurav seems to like superhero movies, right? So if we were to choose between these two movies, it's likely going to be, let's say, Batman Returns, and we are not going to show Fight Club because Gaurav doesn't like it, right? So similar to this is kind of our internal learning on how we figure things out. Similar to this, what we do in machine learning is we give a lot of input data to the model. We'll come in a second on what a machine learning model is. We basically get a lot of this data, and we train something that we call as a machine learning model. A machine learning model in itself is, think about it as a complex mathematical equation, which is full of like matrix operations and calculus. I don't want to go into details for that. So I want to give you a very simple mental model that you can hold on to as you are trying to think about these concepts in future. We are talking about something called supervised machine learning for those who know this term. Those who don't know, don't worry about it right now. So the simple mental model on what a machine learning model is actually, it is just an equation. And imagine for simplicity purposes that equation looks something like this: W1x1, W2x2, and W3x3, where Y is the prediction and X1, X2, X3 are the inputs that we are taking in to make that prediction. Now, what this model essentially does is it will take the inputs from the training data and it will train this equation. So X1, X2, X3 are inputs, which will be, let's say, the genre of the movie, the actor of the movie, and so on and so forth. And Y is the prediction, which is whether I like this movie or I don't like this movie. It will run this equation through like all of these parameters and try to train these W1, W2, and W3s. And once you have used all the training data, you get the final equation, which would potentially look something like this, for example. So now you have the weights, and now you are actually ready to use this model in your production use case. So let's say when the Batman Return movie comes in, you put in the X1, X2, X3 of Batman here. And based on that, you get a prediction that, okay, yeah, this seems like something that Gaurav would like. So just to recap, this is a very important mental model because a lot of people get confused on what exactly is a machine learning model. So in summary, a machine learning model is essentially just a set of equations. It is done using calculus and matrix operation, but a simple mental model is to think about it as a mathematical equation, which takes in some input and gives out an output. Cool. So hopefully that gives you some idea. And then just to help understand what is the difference or how are machine learning and AI related. AI is a concept. It is a science of making machines intelligent. So it's kind of a unlimited goal. You can kind of go on and make machines intelligent to a vast degree. Machine learning is actually a means or a special technique that actually enables us to achieve that artificial intelligence level where things are actually as intelligent as humans are. So hopefully that demystifies a little bit on what AI and machine learning are and how these things are related. Cool. So let's jump into the second section of the talk today, which is around types of ML solutions. So in this section, I primarily want to give you an overview of what are the different types of solutions that are out there, and just to give you something to like hit the road as you are thinking about options within the company. So there are, at a high level, I would say 3 ways you can potentially start using machine learning models in your world at a high level. The first one are ready-made solutions. We are going to go through some of these. These are solutions that are already created by companies like major cloud providers or startups, and you can just plug and play. The other is you actually have to maybe take some of these models and retrain them with your custom data. So essentially you are recalculating W1, W2, W3 on your training data, but the equation actually remains as is. And then the third one is you're actually changing the equation altogether to build a new custom model. So let's look at each of these one by one. I'm just going to switch screens here to give you a quick sneak peek into how this looks like on Google Cloud Platform. There are basically, we're going to go through 3 of these: computer vision, text to speech, and natural language understanding areas. And again, as I said, these are not related to just Google. A lot of other providers also have this. I'm just taking an example of Google because I'm kind of aware of this. So if you want to get to this page later, you can go to Google Cloud homepage, and then you can click on products and AI and machine learning and vision AI. So let's see what kind of ML solutions can you get on vision related use cases, which is essentially image recognition. So I'm going to quickly pull up an image and drop it here. And now what we are trying to do here is we are trying to understand what a machine learning algorithm that can understand images can do for us. And then in the next section, we'll get into the specific use cases. I just want to give you a sense of what the territory looks like here. All right, so I uploaded this image. This is from my Halloween party. And this API basically does a few things here. The first is it identifies what the objects are. So if you see an object label tab here, this essentially identifies the objects here. Now it identifies that there are squashes, and it kind of gives a bounding box with respect to the squashes. So by the way, pumpkins are a type of squashes. And then it also identifies a table, and it gives you a bounding box with that. And it also suggests what is the probability by that it thinks like it is a table or it is a squash. So it thinks like it's 68% there's a 68% probability that it is a squash. So yeah, so once you give an image, it can identify what are the objects within that image. So that is one. Let's move on to the second tab. The second tab is the labels that might be associated with this image. So instead of identifying the objects, there could be some other concepts that may be related to this image. So for example, this is an interesting one, which is trick or treat, which is a very Halloween-y kind of concept that is used in US. So it's not an object, but it's a concept, and you can kind of get that concept from the image that has been uploaded here. And there are a bunch of other concepts you can see, like furniture is another concept which is related to table, for example, right? So this was the second tab. And let's move on to the third tab. Here, it is actually trying to understand the text which is present in the image. So if you see here, I'm just going to remove this. So if you see here, there is a mantle here which says RIP, right? So it identifies that there is like RIP written there, and it kind of puts it in a block. It also misidentifies a few things here. So for example, it identifies there is a text written here below the table. There is nothing there, but it misidentifies the text written below there. So that we'll cover in the future, that algorithms are not 100% accurate, cannot be 100% accurate. And then there are a few other things around colors and safe search. So it could potentially identify if there is something adulty in the image. So if you have an app which is like Instagram, and you want to filter out content, adult content, then this could potentially help with respect to that. And then there are a few other labels. So this is an example of Vision AI in terms of what are the machine learning models in the vision space, and what kind of ready-made solutions do you already get from, let's say, using a Google Cloud platform. Cool. So let's jump on to the next ready-made solution, which is around text to speech. This essentially means that the machine learning models can actually take any input and generate a speech for them. So to give you an example, let's cut this down a little bit so it's not too huge.
Google Cloud Text-to-Speech enables developers to synthesize natural-sounding speech with 100+ voices, available in multiple languages and variants.
So you see what the machine learning model here is doing. It is essentially taking a text which is written, and it is reading it aloud in a human-like voice. Now imagine the implications of something like this. If you have an ebook, you can actually create an audiobook directly out of this. Or if you have a news article, you can actually just add a Chrome extension using this, and then it can actually read it out when you're on a subway, instead of kind of you having to read the line when the vehicle is shaking in some sense. And then there are some cool things that you can do here with respect to increasing the speed or tempo and so on and so forth. So this is the second ready-made example that I wanted to share. And let's move on to the third one. This is, by the way, called text to speech. So essentially you take a text and you generate a speech out of it. And let's take the third one. The third one is related to natural language. So this is essentially means natural language understanding. What we mean by that is, to interact with machines, we write Java, C++, C#, and a bunch of other languages, right? But it is not human or natural language, right? Imagine we talking to each other in that language. That's like not possible. So what we are trying to do here is help machines understand the natural language that humans speak in. And what do I mean by that? There are different facets within understanding that natural language. So this ready-made API helps with understanding some of the concepts that get discussed in a natural language. So let's take an example of a sentence like this. Bose headphones are great. Let's get them for Sam this Christmas. And oh, I actually already ran this, but just quickly copy the text. I think I have it written somewhere. Yes, I have it written here. All right, text to speech. So we hit analyze, and it basically gives me a few things here with respect to the thing that I've entered. So this is a natural language. I might potentially say it to a friend. And then within that, it helps me identify these 4 or 5 things. The first one is entities. Entities is essentially being able to figure out what is being talked about, like what is the major thing within the conversation that is being talked about. So here it is about headphones, which is also a consumer good, it tells me. The second is Bose, which is an organization, and it identifies it clearly. And then the third is Sam, which is the name of a person, and it again identifies it clearly here. So imagine like the kind of things that you can do when you have a natural language statement. You are a customer, you have a customer support tool where the written text from customers actually come in, and then based on that you can identify, okay, what product are users talking about? Oh, they're talking about headphone but not sound bars, and so on. So you can do a bunch of interesting things using something like this. The second is sentiment. So sentiment is essentially like positive or negative. If I'm happy with my headphones, I would say like, hey, this is like an amazing headphone, it's a positive sentiment. Otherwise I would say like, hey, this sucks, and that's like a negative sentiment. So here you can clearly see that with respect to headphones, it identifies a magnitude of 0.9 in green, which means the sentiment is positive for the headphone. And similarly for the organization, the sentiment is 0.9 again, and it is positive. Versus interestingly, if you see, that the sentiment score for Sam is neutral, because we are not talking positively or negative about Sam. We are actually talking positively about the headset, and it clearly identifies that here. So again, let's take an example of customer support use case. You can clearly identify which product users are talking about, and are they actually happy with it, or they actually have a negative sentiment for it. And then there are a few other things that the NL API can actually help you do. It can actually help you parse a bunch of things from, let's say, what are the different parts of speech within a sentence. So you can do kind of more upstream natural language understanding applications on top of it, and so on. And categories. I don't know what the categories exactly mean here, but we can play it around with the longer sentence and see. So I hope you get a sense of what each of these three are in some sense. The computer vision, where it takes an image and identifies objects, and it can identify if there's something adult or not, and so on and so forth. Text to speech, where it generates a speech given an input text, and natural language understanding, where it actually parses the natural language we speak in and try to add an understanding around it. These are just some of the ready-made solutions that many cloud providers, including Amazon, Azure, and many startups also provide. And there are many other such solutions that you want to play around. Feel free to go to one of their websites and try out their test API for free. So these are all what happened? Cool. So as I was saying, these are all ready-made solutions that are already existing out there. Let's get to the second one, which is retraining the model using custom data. So now that you know that a machine learning model is essentially an equation, right? And in some cases, or in a lot of cases actually, the ready-made solutions would not be sufficient for your use case. You will have to kind of build a model or a solution that is more nuanced for your use case, because only you kind of know your use case the best. So let's take an example of petfood.com. I don't know if that's a site, I just made it up. Let's imagine you are a product manager at petfood.com and you want to launch a new feature where the users can actually take a picture of their pet and upload it. And then based on that, it can just recommend what kind of food your pet should get. Like instead of searching, you're a new pet owner, you don't know, instead of searching, you just like let the picture do the talking for the user. So now your use case is you take a picture from the user and you recommend them the food items for their particular pet. So imagine that none of the major providers actually have this model, like doesn't do this particular task, which is identifying whether it is a dog or a cat. For simplicity, let's take these two. Now what you do is you actually create you actually train a model using your input data. So you would still take the equation from, let's say, the image recognition model that Google has, for example, Inception. You don't have to know the name, but if you're interested, Inception is like one of the top image recognition model. So which essentially is, let's say, in the form of an equation. And what you do is you actually retrain that model, or there's something called transfer learn that model using some of the images or the data that you have on your side. So you're just modifying these weights W1, W2, W3 from what they have been in, let's say, a ready-made solution. And then based on this, you get a trained model. This trained model, as you can see, like I've changed around the weights here a little bit. So the weights are different. So if you give an input which is different, you get like an output for your particular use case. So the second way you can potentially start using ML solutions is actually taking a standard model like Inception and just retraining those weights using your own custom data. Awesome. And then the third way you can potentially use is through new custom architectures. So here you are actually changing the equation completely. So the equation is not y is equal to w1 x1 plus w2 x2 plus w3 x3. It could potentially be y is equal to w1x1 square plus w2x2 cube, and so on and so forth. So you can like totally have a different equation in this case, and you are actually developing that new model for yourself. So this is just an example to show you how the models get constructed. This is essentially a graph which is used in TensorFlow to create these models. You don't have to worry too much about it. I just wanted to give you a sense of like the model here would essentially mean the components are fitted in different manners and with different like intensities and so on. So yeah, so 3 ways you can start using things. The first one, as I said, is just quickly go back. The first one, you can use ready-made solutions. You can train your own model with custom data, and you can actually build like new equations altogether. Cool. So let's move on to some of the some interesting case studies in products, and yeah, in this one I want you guys to I want you all to kind of work with me through in the chat if you can. So, I'm just going to mute whoever is whoever has his microphone on. Awesome. Looks like it was Pushpendra, I think. Cool. So let's dive into this, and I want you guys to work with me on this. Can you maybe tell me 1 or 2 or 3 use cases of how machine learning or AI actually can be used in e-commerce product? Let's take an example of eBay or Amazon or Flipkart. Feel free to post your ideas in the chat. Cool. So I'm looking at the chat now. Okay, reviews, recommendations, targeting for ad campaigns, show photo to identify fashion item, demand forecasting, advertisements, sorting of results. Awesome. Yeah. So I think risky users and fraud, computer vision for interest fraud. Yes. Awesome. I think these are all great ways through which we could potentially enable the e-commerce experience within the apps. Let's take a few examples that I had here. I think some of you already mentioned this. One could be object detection through camera. So you actually just point your camera to, let's say you have a segment in eBay where you identify a product, you click on it, the camera starts, and then you can point it to a shoe, and it helps you identify what that different type of shoe is, right? So this could be like a simple object detection model. The second way is, let's say this is a slightly more nuanced in natural language space. Let's say you want to understand why are users returning the items automatically. Like right now, probably somebody sits and manually tags them, or you ask the user to tag it, right? Instead of doing that, can we actually let a machine learning algorithm tag why something was returned, for example? So in this case, you will create like a custom machine learning model, and the training data that you would potentially have would look something like this. You have the sentences which are coming in from the users, and then you label them with certain categories. So let's say if the user says the box was damaged during delivery, you identify this is a delivery issue. Camera does not turn on, it is like item defective or something of that sort. Now, these categories can be very custom to your use case. Maybe Amazon doesn't care about defective products or delivery issues, or they have like 10 other categories than eBay, for example. So you take the input, the data that you may have from the users and which may have been hand labeled, and then you train a model using this input data, which is a custom model. So this is a simple text classification problem, multi-class problem in some sense. And you take the return reason, which is in natural language, and then you predict the category from it. So these are just 2 ways on how AI can be used in e-commerce products. There are like 50 others that you have all mentioned, and I think they're totally valid in terms of personalizing the page or suggesting the right items or like voice search and so on and so forth. Cool. So let's move on to a slightly different use case in maybe a hybrid hardware plus software world. So if you can take onto the chat again and tell me how does, let's say, a hardware product like Apple Watch could potentially use machine learning or AI? Prediction of activity, yes, that's a good one. Fitness alert, okay, I don't know what that means. Sleep quality, yes. Suggest increase in weight, that may not need machine learning. Suggestion of workout types, predict health issue, health monitoring, abnormal heart activity, reminder to do. Yes, these are there are a lot of good ones here. Detect symptoms, user profiling, absolutely. So there is a lot that can be done with the data that comes in an Apple Watch. The first one that I had here is, a lot of you have already mentioned, that is let's say heart issue prediction in some sense. So your Apple Watch actually can track your heartbeat, and then from the heartbeat it can actually suggest what kind of issues the user may have. So you will actually build a custom model in this use case, where you would actually take the heart rate data as an input and predict the issue category from that. So like, what is the probability that somebody might have a stroke, or what is the probability that somebody has like irregular heartbeat and should get it checked, for example. So that's certainly the first. And then the second, I think somebody also mentioned, was around activity prediction. Here it essentially, you would again train a custom model for this, where you would take the movement sensor data, and then from that sensor data you would actually predict if the user is running, walking, cycling, and so on. Fintech, I think this one is relatively, somebody already called it out in the e-commerce case. I'm not gonna do Q&A here. Let's move fast on this. So fraud prevention is like a very big use case for machine learning. You could potentially use a solution out there and retrain it with your data, or you can build your own custom model. In the fraud prevention use case, you would have information about previous transactions, for example, and then based on that, you can predict if something is fraud or not. AI in education products. This was something that actually somebody had put in the questions in the form. I'm curious to know if you can suggest any ideas in terms of how we can use AI in educational products. Okay, personalized learning. Hey, Uday, thanks for the question. Learning path based on student ability, yes. Tracking deviation sites, absolutely. Auto grading chatbot, yes. Based on assessment, we recommend courses, yes. Recommendation, absolutely. So I think these are all great ideas. The one or two that I had added here are, one is, let's say, just helping students find the right lecture or solution for a problem that they are struggling with. So let's imagine the user is struggling with this equation. We actually take a picture of this image, and based on that, we use a ready-made model, which could be, let's say, an OCR detection model, which could detect the characters on the screen. And the custom model, so the first part here would be a ready-made model, and then the second part here would be, you would take a custom model and where you would take the OCR text and try to map it to, let's say, the math topic, which could be, let's say, quadratic equations in this case. Awesome. And then the second use case is, I was just chatting with one of my nephews, and they are now having like online exams. So like video and that trend is, I think, only going to grow over the years in general. So like video proctoring could be an interesting use case, where you can actually use the front facing camera, and then based on that, you can do facial recognition and just make sure that, oh, this is the same person who's actually writing the exam, and he's not like looking here and there, and his facial expressions are not weird, and so on. So instead of somebody like a teacher manually looking at the screen, a computer does it for you. And only in the case where something off is detected, the teacher kind of kicks in, hey, Akash, we shouldn't cheat. So yeah, these are the two use cases. And let's do a final one. This was again a question that somebody had asked, which was around how to use AI in aviation products and operations. Curious to see what people come up with respect to how we could potentially use it in AI, how we could use it in aviation products. Radar collision and path detection. Yes, sure. Weather prediction, yes, that is a good one. Better autopilot, absolutely. Wear and tear of service, yes. Automate repetitive tasks. Sure. I mean, which tasks are we talking about? Cool. Yeah, I think there's some really good ones there. So the one or two that I just had, somebody also mentioned it in the chat here. Predictive maintenance could be like an interesting one here. Aircrafts usually have to like airlines usually have to like face delays because there is some maintenance at the last minute that comes up. So with respect to sensors, if we can figure out when the failure is going to happen. And then the other one is within the airports, let's say this is more around operations, we can actually do like video surveillance. Video surveillance happens right now, but it's very manual. Like somebody has to actually sit and view those screens instead of
Hey Gaurav, we lost you.
Not audible, Gaurav.
hey, can you hear me now?
Yes, we can.
Sorry, for some weird reason, it connected to my Bluetooth headset. Is the voice clearer now or?
It's clear.
Oh, I see. So all this time, my headphone was, I don't know where my headphone is actually. Cool. Let's roll. I think we are running a little short on time. To the last section, which is just the considerations. And yes, oh, that was a Bose headset. Let's move on to the considerations and resources. What are the kind of things that you have to think through as you are thinking about using ML in your products? So the first one is obviously build versus borrow. We touched a little bit on the ready-made solutions and building custom models. But at a high level, this is like a general advice. Like if you need a standard solution for your use case, please don't try to build a model again. I think some of the companies have done a really great job to build these models. For example, OCR detection or simple object detection or text to speech. Just use the APIs. It'll be much faster to get things running. The second is custom training with standard architectures that I was talking about. So essentially just take the inception model or other models and like retrain those models using your data. This is probably the one that you will have to use a lot if you are doing like nuanced activities, which I'm sure most of you would be doing. There is a solution from Google, which is called Google AutoML, which essentially abstracts away a lot of details. And all you have to do is just provide your training data. And based on that, it will automatically identify which architecture or which algorithm is good for you and give you an output model. So it abstracts away almost everything, and it makes it like super easy for you to train your models and see how the models are performing. So do try it out. And I think if you end up taking the Pragmatic Leaders AI course, Pallav has a great set of case studies that actually goes into detail and probably uses one of these like automated machine learning frameworks, either from Google, AWS, or Microsoft. And then the third one is building custom models and architectures. You likely need like a data scientist if you're not already one for this, and use this for use cases where the architectures may not be available. So if you want to build, let's say, a 3-layer model neural network and you don't have it, then you can use it. Or you want to do like very cutting edge research and try out new things, you could potentially use, let's say, TensorFlow or PyTorch libraries and kind of work through that. Cool. The second considerations as you're thinking about this is like hammer this point in your head as much as you can. This is probably the most important slide on this slide in this presentation. This is very interesting on how Ratnesh is able to do that on my screen. Yeah, the TLDR of this slide is that your model is only as good as the data that you provide. And that is the reason why machine learning engineers and researchers spend more than 80% of their time in tasks related to data. Like model training and stuff probably is like 15, 20 lines of code most of the time. All other efforts actually go on preparing the right set of data, at least for supervised learning. So spend a lot of time with data. It's a simple equation: garbage in, garbage out, quality data in, quality model out. One thing that I want to really emphasize is this concept of bias in models. Like if your training data is biased, in that case, you won't have good models. And we do not, as product managers or leaders, we do not want to live in a world where we are replicating the bias of the real world. For example, if people of color feel like our like world is not fair for them in some of the use cases, for example, we don't want those biases to continue in algorithms. And that could easily happen because if your training data has let's say 90% white males for facial recognition, obviously your model won't be recognized, let's say, people of color or black people in an efficient way, right? So training data is like super important. And then the last one is understand the model performance and the trade-offs. Your machine learning models will never be, let's say, 100% accurate, or in most cases won't be 100% accurate. So you will have to deal with some level of uncertainty. But to understand that, there are these concepts that you should like really grasp. In the interest of time, I'm not going to go into details of this, but there are these like 3 or 4 concepts. If you understand them well, it's you can kind of read the models really well. One is the concept of precision, the other is recall, and then you can have F1 score and the area under the curve. Awesome. And the last thing I wanted to leave you before getting into Q&A is some resources on how you can go about like getting your feet wet with ML. So you can obviously take courses. Pallav runs a great course, so try signing up for that. Coursera has a bunch of very interesting courses from this professor at Stanford called Andrew Ng. He's like considered as one of the very renowned people in the field of machine learning. The first one, which is AI for Everyone, is a general course. It doesn't get into technical details, versus if you want to get your hands dirty with TensorFlow and stuff, you can take on the machine learning course, which is like an introductory machine learning. The second is try building models with Google AutoML or similar, the one that I had previously mentioned. It's very easy. Just take 10 images, label them, upload them, label them, and then train a model. Play around with it to get a hang of things for yourself. And the last one is like as much as possible from product side of things, I always encourage people to evaluate the things that they are using, how it is using machine learning. So next time you open your Android phone, if you have one, you will see like 5 recommended apps at the top. That is coming from machine learning. If you go to Google search and type something, the recommendations or the rank of the pages, the blue links, are actually coming from a machine learning algorithm. So think about where all people have been using machine learning. So that will give you a good mindset on how to use it in, let's say, your products as well. And another interesting thing I do is I keep a tab on Crunchbase or similar sites to just understand what are the AI startups coming in. This is usually interesting to see like what kind of cutting edge research is happening in the world as well. I personally get to see a lot of it within Google, but for those who are not working in core research areas of AI, I think this is a really good source to keep track of what are like the new things coming up. Awesome. So with that said, I'm done with my presentation and I'm happy to jump on questions. Piyush, if you are still around, do you want me to go through some of the questions that were shared in the tricks
Yes.
in the spreadsheet?
So, right. So before we begin with the Q&A, first of all, thanks a lot, Gaurav, for such an insightful session. I hope all of us have got some little crisp brief about what it takes to leverage AI to build better products. Pallav, do you want to add something before we start with Q&A?
Right. Thank you, Gaurav, for pulling in such a like in such a short time, such a comprehensive presentation together. What I loved about the whole thing is, and I was amazed. I don't know. I was expecting that some kind of technical Python or some PyTorch or something of that sort coming in, but what. What my understanding and what you presented very beautifully were the two approaches where you said one is you can take the model as an API. Second is retrain the existing models. And the third is that the third step, you look at building your own model, and that is very critical, and which is one thing that during our preparation of the course. So it was like took us a good 1 year to just, there was an internal fight between all of us that should we do Python or should we do the first two approaches, right? And I think somewhere I was able to convince Talvinder that the first two approaches are more critical, because as a product manager you're working on developing a solution and then designing a solution for that matter. And that is what we have tried to capture, as you rightly said, in the course that we are working on, and then that's going on right now. So just before we get into the Q&A, just wanted to share the modalities, if I can, of the course. Is that we are closing the invites by 30th of November, and so the last few seats are are left. Just to put in the perspective, it's a simple 8-week program with the first 6 weeks, getting you to learn AI so that you can apply as a product manager in your organization. And the last 2 weeks is to make you industry ready and make you actually a person who can apply and have a profile worthy of being called an AI PM. So that's what it is. Now over to you, Gaurav, where you want to share some